Hello, welcome to the video. This is my submission for assignment number 2 in nature inspired computing class room allocation using PSO. This is the assignment question. Here, this is a real world problem. Here, 40 rooms are there and 56 students are there, out of which 28 are boys and 28 are girls. Each student has given his preference to rooms, and we have to allocate the rooms such that maximum of the students should get their preferred rooms. They have given a list of rooms and the list of their preferred rooms. There are certain constraints like no student should be allotted worse than 20th choice, but in real world it's up to 22 or 25. And there are some double capacity rooms and single capacity rooms. And in double occupancy rooms, either there can be two boys or only two girls. Like that, there can't be one boy and one girl. This is a room allocation real world problem, and I enjoyed a lot solving this problem. So here is the code for room allocation using PSO. I have implemented this algorithm in Python. So here is my code. Around 300 lines code. This was a real world problem, so I enjoyed. So first we read the Excel file that was given to us in of the preference list, and using the pandas library, we converted it into the matrix. And this is the capacity we have got of single and double rooms. And here I have taken out the single and double room IDs separately. After that, we set the population size of 100. We can set population size of 50 and 200 also. So after initializing the population, we will first initialize the population, and girls are given preference while initializing the population. So while initializing, we are adopting simple logic like first we will fill the 16 double rooms, and after that we will flip a coin. We will flip a coin, and if the coin comes out to 0, we allocate that double room to two girls, and if the coin comes 1, we allocate the double rooms to two boys. In this way we allocate the 16 double rooms to boys and girls, and after that 24 students are left and 24 single rooms are left. Again we give the preference to girls as it is ethical to we allot first all the remaining girls single room, and then we allot all the remaining single rooms to boys. After that we find the fitness value for all particles, uh, and we in this way we initialize the population. After that we calculate the g best, which is the first element in the population minimum, which has minimum fitness. This is the parameter for the PSO algorithm. Here one new thing is g best list. It is for our last output. This is the selected preference of each student. Like they have given the preference list, and but which preference do they get at the last? It is the g best list. It is generated per generation. Like for we run the code for 200 and 2000 generation, then g best list will be of 2000 length. After that we sort the population and p best according to the fitness. Now we come to the PSO algorithm. Here we set the inertia coefficient as 0.4 and C1, C2 as 0.79 and 0.73. These are just random numbers. We can directly give random dot random also for these factors. C1 is personal acceleration coefficient and C2 is social acceleration coefficient. Here is the main loop. I have run the code for 2000 algorithm and reported the result for 2000 generations, but for just time's sake, I am running it for 20 generations right now. So for each population, inside this loop, for each particle in population, we update the velocities according to the PSO rule, and then we update the positions. With this is a simple formula which depends on C1A, C1 and C2, that how much we believe in P best and how much we believe in G best. These are C1 and C2. After that, we again we have to allot the rooms to the boys and girls from the preferences that we have got in the form of pref 0. So for that we have done some initialization, like which girls are left, which boys are left. Allocated rooms. Allocated rooms is just like the rooms that each student has got. It is a dictionary in which a student is the key, and its room is the value. This is single boy double room ID, this is single girl double room ID, empty double room ID, and empty single room ID. After that, now comes the room status. This room status is the dictionary where room ID is the key, and the students who have given preference to that room number or all these students for that key. There can be multiple students, like 3 4 students who has given the same room ID as their preference. We have set the preference limit as 20 25, and we have seen that for better, without taking the code, we can do it for 25 first preferences, like that. After that, there is a room allocation based on the student preferences. So here is the code for allotting rooms according to their preferences. The rule is simple: if the room is double room, and if the number of students who have filled that room is greater than 2, so if there are 2 boys, we allot the room to 2 boys. If there are 2 girls, we allot the room to 2 girls. But if the double room is double, and if a single student has filled that room as preference, we will allot that room to that guy, and it will be appended to that double room singly filled type list. And if no one has filled that double room as preference, then we will allot it to the double empty double room ID. We will allot to these lists. After that, we will come to single room allocation. Single room allocation is if any guy has filled that room as preference, we will allot that to that first guy who has preferred this room. And after, if no one has filled that room, we allot that single room ID to the empty single room ID. Now, after these preference based allocations, now comes the our left for left boys and left girls. We allocate the rooms based on our intuition. This depends on the accuracy of our model. First, what we do is the rooms that were singly filled by boys, we see if there are any leftover boys, we give it to them. And if the double rooms are singly filled by girls, and if there are more girls left, then we allot that one more girl to that double room. In this way, the double room gets fully packed. Here is the for double room allocation. Now at last we have some left boys and left rooms, and we have only empty double rooms and empty single rooms. So again, girls are preferred as that is ethical. So we allocate the double rooms to 2 girls if they are available, to empty double rooms, and after that we allocate it to the double room to 2 boys in the group of 2. After that, all the empty double rooms are over. There are no empty double rooms. After that, we fill the empty single rooms. Again, girls are given preference, and then the boys are filled. So after doing all this intuition-based allocation, all the rooms are perfectly allocated. The allocation of rooms, we find the new position for each particle after the new allocation. These are the preferences step 0. Again, we calculate the fitness and update. If we got the preference less than the p best that was previously we have seen, then we update the p best, that is the each particle on best. And after that we came out of the loop. and then we again sort the population and p best, and we update the g best. That was if the population has seen lower g best than that was previously seen, then we update the g best. After that, updating the g best, this was previously the thing g best list, which is the selected preference of each student per generation, like which preference of each student is taken at last. So after at last we print this g best allocation, and this is after all that we will save the gbest list in the excel as access form to feed it into the matlab to plot the uh, optimum solution. So this is my code. So I will make my code run for only 20 generation. I have run it, reported the results for 2000 generations, just for showing that my code is working really fine. This is just for 20 generation. It will not converge, it will not give good value, just for showing. So as you can see, just for our 20 generation, the fitness value we have got is 868, and my code is quite fast. So as I have saved the gbest list in this gbest list 7.xl access form. So here is the MATLAB code for running, showing, seeing the generation wise allocations, preferred allocations. Here is the code is scatter xy. Simply, I will print the iteration number and the fitness value achieved for each generation. So I am running the code. So the code has started. The code is for 2000 generations. As you can see, initially there are a lot of variation. The all the particles are moving up and down, but afterwards, as the iteration goes to 500 or after that, it will get saturated and it will update very slowly. So basically, x-axis is the student ID, 0 to 56, sorry, 1 to 56, and here is the preference that we have taken of each student. Like for first student, the 12th preference is taken. For fourth student, first preference is taken. So we have to, what we have to achieve is all the preferences less than 20 or something like that. The best we can achieve. So I will keep this running. You can skip the or fast forward the video, as there are lot of iterations, 2000 iterations. The fitness value is reduced to 777 right now. And there is a lot of fluctuation initially, because this is a real world problem, and PSO has some convergence issue initially, but for larger number of iteration, the fitness value will get saturated at lower value. You can skip the video. As you can see, the maximum of the particle are coming below this 20 or 25 line. That it denotes that everyone is getting its preference lesser than 20 or 25. Some are getting above, but it will saturate after some time. As you can see, most most of the students after 1000 iterations only have got reduced, have got the preference lesser than 25. Only two students have got greater than 25 preference, but that will happen because it is a real world problem. As you can see, it is much more like densely all the particles are densely below 20 and very few particles are above 20. As it is a real world problem, one or two students may not get their preference, like this has got its 20, 32 preference, but most of these students have got the preference below 5, and we can say 70 to 80% of students have got till their 10th preference, and 90% students have got till 20th preference. The iteration number is 1400, but it is, I think, saturated now. Let's wait till 2000 iterations because I have saved the XLSS file till 2000 iteration. As you can see, this has saturated the fitness value to 558 after since a long time. So the all the iterations have completed and the fitness value we have achieved is 558. These sometimes get to 460 and 450. Sometimes it gets to 555 and around 500, like this only. Because there are some random values allocations also. So this is my submission for room allocation using PSO. I enjoyed this assignment a lot because it was a real world problem. Thank you.